Howdy AGP students, this lesson will continue with functions and focus on the graphing of functions. Some problems will not give the actual function, but will provide a graphical representation of the function. These problems will typically ask for the output or input. Let's first review coordinate plane systems. This is a fancy way of simply saying the x-y axis. Points are presented in an ordered pair system with the x and y values listed inside of parentheses. These points are always presented as x, y inside of the parentheses. The x value will always be first and the y value second. The x values run along the horizontal axis while the y values populate the vertical axis. Be careful with these ordered pairs. Almost always an answer choice is presented with the order incorrect. For use with functions, the ordered pair represents an input and output value. The x represents an input while y equals the output. Graphs can be altered by making minor changes in the function. Two general rules should be followed when dealing with graph shifting. First, changes outside the parentheses affect the graph vertically, up and down. Next, changes inside the parentheses affect the graph horizontally, right or left, and act in the opposite direction. Let's take a look at some examples of graph shifting. These two graphs alter the function outside the parentheses and shift the graph up or down. It may help to think about this as an addition or subtraction to every point after the rule is applied. So here on the graph on the left, you can see that plus 2 was added after the function, so every point shifted up 2 values. And then on the second graph, or the one on the right, 2 was subtracted from the function, so every point was lowered by 2 on the graph on the right, shifting the graph down 2. Next we have examples of a change inside the parentheses. This will shift the graph to the left or right in the opposite direction of the sign. On the graph on the left, you can see that 2 was added inside the parentheses. So this is actually going to shift our graph to the left or in the negative direction, 2 places. And then on the graph on the right, we subtracted 2 inside the parentheses, shifting the graph to the right 2 places. Our next example shows the effect of multiplying inside and outside the parentheses. When the entire function is multiplied, the graph stretches vertically. This can be seen on the left. The function was multiplied by 3, and so it stretches up 3. And so if you see, the y-intercept is at 2, but the new one is at 6 because 3 times 2 is 6. On the right-hand graph, the multiplication is inside the parentheses. The output actually compresses horizontally, and so you can see that the graph has been smashed horizontally. The last examples we will look at flip the graphs along the horizontal or vertical axis. When a negative sign is placed outside the parentheses, the graph is now the inverse or flips along the horizontal axis. When the negative sign is inside the parentheses, the graph flips along the vertical axis. So on the left, you can see that the negative sign was placed in front of the function, and the graph is a mirror image of the original. Whereas in the right-hand graph, the graph actually flipped along the vertical axis. Let's now take a look at our first example problem. This problem reads, let h of t be defined for -1 less than t less than 6. Find h of 2 with the graph. So here we can see we have a line on a graph, and we're asked to find h of 2. To find this value, we locate the point where x equals 2 and then locate the y value to give us the output. So we can see here that when x equals 2, y equals 7. So h of 2 equals 7. And that's all you have to do. Our next example reads, find h of 1 minus h of 3. So again, we're given a graph, and we have to locate these two outputs on the y-axis and then subtract them from one another. So our first is h of 1. So when x equals 1, y is 10. And then when h equals 3, y is 4. So we simply subtract 10 minus 4 and get 6. So our answer is 6. Our third example reads, if h of m equals 4, then m equals what? So in this case, we're actually given the output, and we're asked to find the input. Take a couple of minutes, look this over, and work it out. And of course, like always, we'll go over this in class.